composition of functions, okay? Composition of functions. You'll remember it when I put it up here. You do it in Algebra 2. Fog and golf is what y'all usually call it, but that's really not what it is, okay? This says F composition G, and actually, it is F of G of X. This is the way I like to write it. It's the way that I teach it from, okay? So, the other one is G composite F, and he is G of F of X. Okay? All right. So, I want to ask a question. So, I need you, the domain is going to be the most difficult part, all right? So I want to make sure that you understand the verbiage that I'm going to use. So, I want to know which one would be called the input function. Okay? Which one of these is the input function, the F or the G? G. He's input. You're putting him in to F. Do you see what I'm saying? Over here, who's the input function? F. Okay? So, when I say input function, tell me another way that maybe you might say it easier.
Domain.
Which one?
Domain.
No.
The one with X. Range.
What if it's written like this?
That's the one on the right.
So the second one?
Second, yeah.
Okay? The second one, the second function. Is input one. Alright, the second function is going to be your input function. Alright, so this is how to find the domain of a composite. Domain of a composite. This is going to be the most difficult part of this lesson. Finding the composite is really not that bad. Maybe last year you struggled a little bit, but when I show you this year, you'll be like, whoa, and it'll be easier. So, when you talk about the domain of a composite, you must consider any restrictions on the input function and the final composition. On the input function and the final composition. So when I start talking about the domain of this composition function, you're going to have to look at the input function's domain and the final composition's domain. And you have to consider both of them. Okay? You have to consider both of them. Has everybody taken your test? Is there anybody in here that has not taken their test? Okay, so let me just give you a for instance, okay? Let's say that the domain of 1 is x is greater than or equal to 2. And the domain of another one is any real number except x cannot be equal to 3. All right? Let's say the domain of our final composition is this, and the domain of our input function is this. What is going to be the domain of that function?
Are we doing it in steps?
Let's just do interval notation right now, okay? Because it'll be easier for me to explain it to you.
Explicit through.
It's this function with the exception of what?
3.
3. That's what it is, guys. All right? Let me show you. This is what it looks like on a number line. So, let's say that this guy right here is the blue. Okay? So, I'll circle a 2. Do I fill it in?
Yeah.
No.
Yes.
You do.
Yes, it has a line underneath it. I kinda drew over it, but it does have a line underneath it. Okay, so that's a solid dot, right? In reading from the variable, it says x is greater than 2. Which way does greater than go?
Right.
To the right. Okay? This function, I'll call him the green function. Can you tell those are different colors? Yes? Okay,
Not really.
so at 3, he can be anything. So he can't be 3, but he could go all the way this way and all the way that way. Okay? So, what would my answer look like? I'm just gonna do interval notation. It has to be blue and green. Where would it start? What?
Inclusive.
It can't be negative infinity, can it? Because there's no blue over here. So yes, he starts at 2. Is that 2 included or excluded?
Included.
Included. All the way to what?
3.
3, and the 3 would be excluded. And then
Union.
union with no tail on the U.
3.
3 excluded,
2.
all the way to positive infinity. Very good. Okay, so do you see what I'm saying about you have to take both domains into consideration? All right, so let's try another one. We're going to do a problem. Okay, are you ready? That was just a pretend stuff. Let's say that f of x is equal to 1 over x, and g of x is equal to x plus 1.
Is there a reason you're leaving so much space to the left? Or like just
Right here?
Yeah.
No, I'm just giving you, they're gonna give you 2 functions and then they're gonna tell you to find stuff. Okay? So I gave you those 2 functions. We're going to find f composite g. Okay? F composite g. Now look, if you're looking at this in a book, I know my penmanship is not wonderful, okay? But how will I know that they didn't just write the word fog?
It'll be a little zero, or a.
Yeah, it's a little bitty tiny, it doesn't look like an O. It's a little bitty circle, okay? It's not a dot, that would be a multiplication problem. It's just a little bitty open circle, so that's a composition function. F composite G.
Is it always gonna be F and G, or is it gonna be?
No, it could be anything. They could call them anything, but a lot of times they call functions F and G, so. But it could be H and K, you've seen it, H and K, they could call anything they wanted to. All right? So, F composite G, I like to rewrite mine like this. F of G of X. Okay? And this is the way I teach it. You've always been taught when you have multiple parentheses that you always work from the inside out. Do y'all agree? Yes? So I'm gonna start right there. Okay? And I'm gonna find F of, what is G of X?
X plus 1.
X plus 1, so I'm gonna plug him in for that. Okay? Now, these are like directions. Okay? He says, go to the F function. Here's the F function. In place of this X, I have put X plus 1. What you do to one side, you have to do to the other side. So in place of every X over here, what will I put?
X plus 1.
X plus 1. So it will be 1 over, there's an X. What do I gotta put?
X plus 1.
X plus 1. That's my answer. You can't do anything to it. Okay? That's my answer. Alright? So, this is my answer, F composite G. Now, we're gonna find the domain. We're gonna do it, even if it has one blank, we're gonna do it 2 different ways. We're going to do it in set notation, proper set, and we're gonna do interval notation. Okay? If you don't know how to do interval notation from set notation, you need to speak up and say, Miss Davis, would you show me how to do the interval from the set? And I'll show you a different way. Okay? So, who do I have to consider? I'm talking about domains. Which one of the functions do I have to consider when I talk about domains of this composite?
Oh,
That's awesome.
Input.
Input. Who's the input?
G of X.
G. So I have to consider this guy's domain. Tell me what the domain of this function is.
All
All real numbers. Why?
No restriction.
Yeah, he doesn't have any restrictions. There are no x's in the denominator, and there are no x's under the radical. No restrictions, means negative infinity to positive infinity. Okay? What about this guy? What about his restrictions? Does he have any restrictions?
Yes.
Yes. There's an x in the denominator, so tell me what to do.
What's equal to, not equal to 0.
Okay, so x plus 1 cannot be equal to 0. Division by 0 is undefined. So I'm going to subtract 1 from both sides. So x is equal to negative 1, or cannot be equal to negative 1. So I have all real numbers except negative 1. Are you with me?
Yes, ma'am.
Tell me what that looks like in proper set.
Any
Any x such that,
All real numbers.
X is an element of all numbers,
very good, x is an element of the reals,
and X is
comma, x cannot be equal to negative 1. Okay? Now, if you want to know what that looks like in interval notation, and you can't go from here to here, then the best thing to do is to put it on the number line. Okay? So here's my number line. So x can be anything except negative 1. So here at negative 1, I have an open circle. What does an open circle mean?
Not inclusive.
Not included. An open circle means not included. In interval notation, what would that be?
Parentheses.
Parentheses. Very good. That's a parentheses. All right? A solid circle means included, and that would be a bracket. Okay? Infinities are never included. Okay? It's like you can't include something that doesn't ever stop. All right? So I can have anything except negative 1. So this is what he looks like. So in interval notation, this is what he is. You always start, interval notation has the smallest number on the left, so you always start from the left-hand side of this number line and you read it. What does the left arrow mean?
Negative infinity.
And what did we just say about infinities?
Never included.
Never included, so you always put parentheses with them. Negative infinity, all the way up until,
Negative 1.
and is he included?
No.
Is an open circle, not included. But then, union, negative 1, not included, all the way to
Infinity.
positive infinity. Very good. All right, anybody got a question?
No, ma'am.
No, everybody good? Okay. So let's try another one. All right, this is example 5. I'm going to tell you that f of x is equal to the square root of x, and g of x is equal to x minus 1. We're going to find two things. We're going to find f composite g, and we're going to find g composite f. So f composite g will be here in my domain. Now people, listen to me. If you missed all those domain problems on that last test, guess what? You have another opportunity to
Correct.
redeem yourself, okay? All right, you want me to let you do it?
No.
Yeah, and see if you know how to do it?
Yes, please.
Okay.
If it's under a radical, is that greater than or equal to?
All right, did y'all get this one? Okay, so So, if you're gonna do both of them, you might as well just go ahead and do all the domains, all right? So, what's his domain?
Right.
Yeah, x is greater than or equal to 0. What's his domain?
All right.
Negative infinity to positive infinity. So, I'm doing the input function, that's this function, he has no restrictions, so I don't have to think about anything. Does this guy have any restrictions?
Yes.
So, x minus 1 greater than or equal to 0. It's under the radical, you take, if the x is under the radical, you take what's under the radical, set it greater than or equal to 0, solve for x, and that is your domain. So, there is my domain. Y'all listen to me. When it's an inequality in proper set, do not put x as an element of R.
I don't know
Okay.
how you got the f of x minus 1.
What is g of x?
X minus 1.
So, now I put it there. Going to the f function. In place of x, what am I putting?
Square root of x.
No, what's right here?
Oh, x minus 1.
Okay, so in place of this x, I put x minus 1.
Oh,
So
okay.
in place of this x, what do I have to put? X minus 1.
What if it was like 2x? Would you have to put a 2 outside of x minus 1?
If this right here was 2x,
No, if the square root of x.
was it 2?
Yeah.
Then, yes, I would have to put a 2 in parentheses, and I would distribute it, and it would be 2x minus 2. Okay? All right. So, this guy is his restriction. He doesn't have any. So, in interval notation, set any x such that do not write x as an element of R. People, the only kind of numbers that are greater than 1 or are real numbers, all right? So you just write x is greater than or equal to 1. If you write x as an element of R and then you write that, I'll take a point away from you. In interval notation, y'all, if you need to and you don't know what to do, take this and put it on a number line, okay? I'm here at 1 and I'm circling it. Do I fill it in?
Yes.
Yes, is the or equal to? X is greater than goes to the right, all right? So where I read from left to right, what's the first thing I come to?
1.
1, is it included or excluded?
Included.
Solid dot is included, that's a bracket. All the way to
Positive.
positive infinity, never included. Okay,
Yes, ma'am.
all right, g of f of x. Okay, so I'm gonna do this, I'll plug him in there. So that's gonna be g of f of x is the square root of x.
Square root of x minus
So I'm gonna go to the g function, here it is. In place of x, I'm putting the square root of x. Uh-oh, there's an x. Square root of x minus 1.
1.
Does the minus 1 go into the radical?
No.
No, it doesn't. Okay, so there it is right there.
Oh, the other one does go on the right one.
Yes. Okay? Now, we've already done these. Now I gotta look at his domain. Does he have any restrictions?
Yes.
Yeah.
There's x under the right.
X under the radical, so you take what's under the radical, so you must be greater than or equal to 0. Solve for x, it already is. So this is the domain that I'm considering. What's the other domain I'm considering? The f function.
Oh.
This one. Well, they're both the same thing. So guess what my domain
The
is?
exact same thing.
Yeah, any x such that x is greater than or equal to 0. Interval notation, 0 inclusive, all the way to positive infinity. All right, everybody okay? Okay, so before we do the next set, I just want to make sure you got one skill. Do you know how to square a binomial quickly?
Yes.
Remember?
Square the first.
Square the first, x squared,
Plus their product.
keep the sign, plus
Their product.
twice their product. Their product is 6 times x is 6x. What's twice that?
12x.
And then plus, square the last. 36. Are you with me? All right, here's yours. X minus 5 quantity squared. You do it.
Oh, you're ready?
Okay, you with me? All right, square the first.
Square
keep the sign,
minus
twice their product, 10x, plus, always plus on the end, square the last. Perfect. Alright, last one. 2x plus 7, quantity squared. 2x plus 7, quantity squared. Okay, you got it? Square the first, tell me what you get.
4x squared.
4x squared, remember to square everything. Keep the sign. Plus, twice their product. Their product is 14x. What's twice that?
28x.
Plus, square the last.
49.
Okay?
Yes, ma'am.
All right, anybody got a question? Okay, so here we go. This is example 6. Okay, example 6. I'm going to tell you that f of x is equal to x plus 2. And then g of x is equal to 4 minus x squared. I want you to find f composite g, g composite f, and my domains. Any restrictions on those domains?
Nope.
No. So, my domain is any x such that x is an element of the reals. Negative infinity to positive infinity.
Oh.
Oh, I got my sign mixed up.
All right, anybody got a question?
Hold on, give me like.
Uh-huh.
I'm still not quite understanding, like, I understand you're putting in the g of x right by like the f, like
Mhm.
before
Like
minus
right
x.
here?
Yes,
Mhm.
but like, where are you getting the stuff on the other side of the equal sign?
This stuff, what, this stuff right here?
Yes,
Okay, I'm going to this function. So there's the f function. In
yes.
place of every x, I put 4 minus x squared. What you do to one side, you do to the other side. So I go over here, and everywhere there's an x, I'm gonna put 4 minus x squared.
Okay.
So all I'm doing really is I'm taking this function and plugging it in for this x,
Okay.
and then I'll take this function and plug it in for that x.
I got it.
All right, everybody okay?
1 second. Wait, why did you put the x in the element of all real numbers? I thought it doesn't have that.
Because there are no restrictions here, there are no restrictions here, there are no restrictions there, there are no restrictions there. So nobody has any restrictions, so x is an element of R. All real numbers. Okay, we got one more problem I'm gonna work, okay? And then I'll give you a worksheet and you can work on yours. All right, so this is example 7. It looks like this. F of x is equal to x squared minus 9. You like his domain? G of x is equal to the square root of 9 minus x squared. Does he have a problem?
Yeah.
Yeah, he's gonna have a problem. Okay, so first of all, I'm gonna address one thing, okay? So, look, people, you cannot take the square root of each one of these and pull those out of the radical.
Oh, that's what I
You
was
can
gonna ask.
only do that if it's multiplied. If it was 9x squared, then the square root would be 3x, okay? But you can't do it. I'm gonna show you why, okay? I'm gonna turn this little piece of paper upside down and over. And I'm gonna do one. I'm gonna go 16 plus 9. The square root of 16 plus 9. What is 16 plus 9? 25? What's the square root of 25? So I know this should be 5, right? If you can do that, it will be 5. What's the square root of 16? What's the square root of 9? Is 4 plus 3 equal to 5?
No.
You can't do that, people. You can only do it if it's multiplied, not added or subtracted. So that's the first thing I want to make sure that y'all don't do that stuff. Okay? This time we're not going to find G composite F. All right? It's a little crazy. So we're only going to find F composite G. So I want you to find F composite G, and I want you to find his domain.
Alright. Wait, hold on. None of the radicals are greater than or equal to?
Mm-hmm.
Oh, never mind, that was good.
You're okay with that?
Mm-hmm.
What does that square do to this?
Cancels out the
That's all it does, guys. Squares and square roots are opposite, so it just makes that go away.
Oh, it's square.
So it should just be negative.
Wait, that's exactly what I
That's
got.
exactly right. These cancel out, and I'm left with negative x squared.
Why not?
Okay? Now, whose domain do I have to think about?
G.
G's and his. Okay, gotta do both of those. So let's look at this domain. Uh-oh. This is quadratic inequality. So, what you gotta do is take what's under the radical and set it greater than or equal to 0. Okay? You need to find the critical values. So, that's factoring. It's the easiest way. So, it factors into 3 plus x and 3 minus x. Are you with me? What's this critical value?
-3.
-3. Why? Because when you go 3 plus x equals 0, you subtract 3 from both sides, you'll get x is -3. What's this critical value?
Plus
3. Because when you go 3 minus x equals 0, and you add the x to that other side, you'll get 3 is equal to a positive x.
What if you do it and then get plus or minus 3?
Plus or minus 3 is good, because that's the same thing I got, right? Okay, so now what we're gonna do is we're gonna put this on a number line. And y'all, actually, this number line is the x-axis on the coordinate plane, because that's kind of how I'm cheating it, all right? So -3 to +3. Now, listen to me, what you can do. Do you agree that these critical values divided that number line up into 3 parts? Left, middle, and right. Everybody agree? If you want to, you can pick a number to the left, like -5. You could put it back in this inequality and see if it made a true statement or a false statement. If it made a true statement, it's part of your solution. If it makes a false statement, you exit out. It's not. Then you can pick a number in the middle, like 0. You could plug it in here. If it makes a true statement, it's part of your solution. If it makes a false statement, you exit out. It's not my solution. Then you can pick a number to the right. Plug it in. True statements are part of my solution. False statements are not.
Can you choose any number?
Now, yes you can. I taught you an easier way to do it. Instead of working 3 different problems, I said, hey guys, look. This is a parabola. How does it open?
Down.
How do you know?
X is negative.
Negative x squared. Okay? So you've got a parabola that opens down. Okay? Now this line divides the parabola up into 2 parts. The hump and these little tails. That's what I call it. Okay? I want the part of this parabola, I'm reading this right here. I want the part of the parabola that is greater than 0. So this is 0, so greater than will be where?
The hump.
Above. Alright? And that would be what we call the hump. Okay? Where are the x's that give you the hump?
Inside.
In between. So these are all my solutions. If that parabola had opened up, you would have wanted the tails, and the x's that give you the tails are on the outside. So actually, I want all the x's between these 2 numbers, included because of this little inclusion sign right here. Okay? So I'm going to put my x in the middle. I'm always going to point my arrows to the left, and that way, logically, my little number goes on the left and my big number goes on the right. It says I want the x's that are greater than or equal to -3 and less than or equal to +3. So in set notation, people, you just go any x such that, and you slap that thing down. In interval notation, there it is right there, people. From -3 to +3, inclusive. See? -3, these are solid dots because of that or equal to.
Yeah, we don't need that.
So -3 to +3, inclusive. Anybody got a question?
No,
No?
pretty easy.
Okay, so, I'm gonna pass out the worksheet, okay? Your other worksheet is due tomorrow, but this worksheet won't be due till maybe Monday or
Do
something.
you know when
Travis, will you stop the video, please? Huh?
our 6 weeks in, is it